Hello, everyone, and welcome. Today, we're going to pull back the curtain on something truly fascinating, the incredibly complex world of aviation safety. It's really a story about how we learn from failure and how every single tragedy has helped build an unseen system that keeps us all safe in the skies. But here's the weird thing, isn't it? We all know the stats. We know logically that flying is way safer than driving our own car. And yet, that fear of flying is so real for so many of us. I think it's because it hits all of our primal fears, right? Heights, being in a small space, not being in control. Plus, one single crash can dominate the news for weeks, making something that's incredibly rare feel like it's happening all the time. And this quote, it absolutely nails it. The whole aviation industry, the entire thing, is built on a foundation of trust. It's not enough for them to just be safe. They have to prove it and demonstrate it on every single flight. Because if we, the public, don't feel safe, the whole system just collapses. That perception of safety is literally everything. Okay, so who actually writes the rules? Who's the one that looks at this massive, several hundred-ton metal tube and says, yep, that's good to go, put 300 people in it and send it 7 miles into the sky? Well, that's where the global regulators come in. You can think of these organizations as the guardians of the sky. The two heavy hitters are the FAA in the United States and EASA over in Europe. They're the ones who certify the planes made by giants like Boeing and Airbus. They work together to create this incredibly strict and, most importantly, standardized set of rules for everything from design and manufacturing to maintenance and flying. Every airline everywhere has to play by these rules. All right, so you've got the best designed planes and the strictest rules, but there's one opponent you just can't regulate. Mother Nature herself. So let's take a look at how the industry has learned, often the hard way, to defend against the environment. Get this, on average, a commercial plane gets hit by lightning about twice a year. Now, for the most part, it's no big deal. The plane's metal skin acts like a shield, the electricity passes right through, and it's usually harmless. But the system had to learn. Back in 1999, a glider was totally destroyed by something called positive lightning. This is a much rarer, way more powerful type of lightning, and it forced a complete rethink of safety standards, especially for newer planes built with modern composite materials. You know, ice is one of the scariest things in aviation. And it's not about the weight, that's what most people think. It's all about the shape. Even a super thin layer of ice, like sandpaper, can completely mess up the smooth flow of air over the wing, basically destroying its ability to create lift. The terrible crash of American Eagle Flight 4184 back in '94 was just a catastrophic reminder of how fast a little bit of ice could become a deadly problem. And in response, the industry created this amazing, multi-layered defense system. It all starts on the ground. You've probably seen planes getting sprayed with that orange fluid in the winter. That's de-icing. Then, in the air, big jets pump hot air from the engines to the front edge of the wings to keep them clear. Smaller planes might have these inflatable rubber boots that literally break the ice off. You add in sophisticated weather monitoring and special ice detectors, and you've got a system designed to make sure ice never wins. But you know what's maybe even scarier than ice? Volcanic ash. This isn't just smoke, it's tiny, sharp particles of rock and glass. And when a jet engine sucks this stuff in, it melts, turns into molten glass, and sticks to the turbine blades, basically choking the engine until it flames out. There was an absolutely legendary incident in 1982 where a British Airways 747 flew into an ash cloud and lost all 4 of its engines. It became a silent glider, falling out of the sky before the crew miraculously got them started again. So, we've battled the fury of nature. But sometimes the threat isn't outside the plane. Sometimes the danger comes from deep within the machine itself. These hidden failures that can build up over thousands and thousands of flights. Here's the key thing to get about metal fatigue. Think of bending a paper clip back and forth. Eventually, it just snaps, right? A plane's metal skin does something similar. Every time it takes off, the cabin is pressurized, and when it lands, it's depressurized. It's like the plane is breathing. Over years, this flexing creates tiny, invisible cracks that can grow and connect until, boom, catastrophic failure. And there is no better example of this than Aloha Flight 243. I mean, this is one of the most unbelievable stories in aviation. In 1988, this plane basically became a convertible at 24,000 feet when a massive chunk of the roof just peeled right off. The fact that the pilots managed to land that plane it's just one of the greatest things anyone's ever done to cockpit. And you better believe this one single incident completely changed how every airline inspects its planes for those tiny hidden cracks. And here, you can see a direct line drawn from tragedy to safety. After a fire on an Air Canada flight filled the cabin with thick, toxic smoke, making it impossible to see the exits, floor-level emergency lights became mandatory. After the absolutely horrific ValueJet crash in Florida, caused by a fire in the cargo hold, well, now all cargo holds have to have fire suppression systems. So every one of these safety rules is a lesson that was written in tragedy. So, we've covered threats from nature, and we've covered threats from the machine itself. But the data is crystal clear on this. The most common factor in aviation incidents isn't the weather and it isn't a broken part. It's us, the human factor. And listen, when people hear human error, they almost always just think pilot error. But it is so much bigger than that. It's a miscommunication between a pilot and an air traffic controller. It's a mechanic who makes a mistake. It's even a little bit of damage that happens on the ground. Or in the most extreme cases, it's an intentional act, like terrorism. Here is a perfect and kind of scary example. A baggage loader accidentally bumped an Alaska Airlines plane and left a little dent in the side. No one reported it, but up at 26,000 feet, where the pressure difference is huge, that tiny dent blew out into a big hole, and the cabin depressurized in an instant. This is exactly why the industry takes so-called ramp rash so incredibly seriously. And of course, no human factor has forced a bigger change than terrorism. Before September 11th, the official playbook for a hijacking was pretty simple. Comply with the demands, negotiate, and get the plane on the ground safely. After 9/11, that playbook was thrown out completely. The new philosophy is absolute. The cockpit door is a fortress, and you prevent anyone from getting in, at all costs, because the plane itself can be the weapon. So you put all this together, the weather, the mechanical failures, the human element, and you start to see the bigger picture. Every single hazard, every accident, every single close call, it all becomes a data point in this relentless, continuous cycle of learning and improving safety. And this is basically how that path works. First, every incident is investigated down to the smallest detail. Then, investigators work to find the true root cause, not just what happened, but why it happened. And that why leads directly to new rules, better training, and even totally new aircraft designs, all to make sure that exact same failure can never, ever happen again. And this quote really brings us full circle, back to that idea of trust. The incredible safety record we see today is not an accident. It's the direct result of decades of intense, collaborative work by everyone, manufacturers, airlines, regulators, all focused on one single goal, proving to all of us that flying is worthy of our trust. So really, a modern airliner is kind of like a flying museum of lessons learned. That reinforced cockpit door, the fire extinguishers in the cargo hold, those lights on the floor, the strict rules for checking for cracks, every single one of those safety features is a silent tribute to a past failure, a way of making sure that tragedy serves to protect all of us in the future.
Which, of course, leaves us with one final thought. Because this work is never, ever done. As planes get more and more automated, and as they're built with brand new materials, the challenges are always changing. So what new problems will pop up? And more importantly, how will the industry continue this cycle of learning to write the next, even safer chapter in the amazing story of flight? Thanks for watching.